This is going to be a video lesson for section 3.2, and I apologize if I'm coughing a little bit. So 3.2 is all about simplifying expressions, and the goal of this section is to combine like terms. So first of all, what's a term? So let me give you some examples of terms. A term can be any number, integer, or even a rational number. So 3, -2, 5, 1.5. These are all terms. It can also be any variable. X, Y, B. It can be a combination of a number and a variable. 2x, 3y. So all of these are terms. Different kinds of terms. So a number, a variable, or a number and a variable combo, where the number is now the coefficient. So these are all terms. Now, there are certain rules when it comes to combining terms. You can combine like terms. Now, what do we mean like terms? We put them in different categories. So constant numbers, or constants, like, let me circle the constants, like 3, -2, 5, 1.5. They're all like terms. All constants are like terms. So any number without a variable is a constant. So they're all like terms. You can combine them, and you know you can. You can combine a 3 and a -2. That's a 1. You can combine a 5 and 1.5. That's 6.5. With variables, you can combine any variable that has the same letter. So you can combine, let's say, I can combine an x, I can combine a 2x, I can combine a 5x, I can combine a -4x, I can combine 2.5x. All of these are like terms. I can combine any of these x terms. No problem. They are all x terms. If I have y terms, I can combine those. For example, if I have y, 5y, 7y, -11y, I can combine all of these. They're all y terms. They also have to be to the same power. What do I mean here? I cannot combine an x and an x squared. Technically, they're both x's, but because they have a different power, you are not allowed to combine these two. It has to be the same. They have to be to the same power. So these, no, you can't do that. Now, this being said, you cannot combine different letter variables. You cannot combine 2x and 5y. Different letters automatically, no. You can also cannot combine any term that has a variable with a term that does not have a variable. I cannot combine, let's say, 4m and 5. That's a term that is a variable. That's a term without a variable. It's a constant. I can only combine other constants with other constants. So that's also no. So I can combine any constants, any variables that have the same letter to the same power, but I cannot mix letters. I cannot mix the same letters to the different power, and I cannot mix terms with variables with terms without variables. So that being said, let's take a look at a few examples. Let's do a simple one. Let's do 3x plus 2x. First things first, identify if you have different types of terms. I have an x term, I have an x term. These are two terms that have an x in them. X to the first power. They're like terms. I can't combine them. They're both x terms. Now that I know they're like terms and I can combine them, I add them. 3x's plus 2 more x's for a grand total of 5x's. Now I didn't change anything here. 5x is the same as 3x plus 2x. I shifted it around a little bit. I changed the way it looks, but mathematically these are equivalent. So these are equivalent expressions. I'm not changing anything here. Let's do another one. Let's go with 2y plus 4 plus y. And let's see what we get here. Here, let's identify our like terms. I have a y term here, a y term there, and a term without a variable or a constant. So I'm going to circle my y terms with yellow because they're like terms. I'm going to group the constant by itself because it doesn't match the y terms. Now I can combine like terms, which means I can combine these two guys. 2 y's, add another y, you get a total of 3 y's. And since I don't have any other constants to group this constant with, it just carries over. As simple as that. Let's look at another example. Let's have 3x plus 4 minus 2x plus 6 plus x equals. First things first, identify different types of terms. X term, x term, x term. I'm going to label them as such. X term, x term, x term. Now, identify my other type of terms. Constant, constant, terms without variables. Alrighty. Now I can combine anything sorry, that isn't a like term. Now one way you can do this, and it's an easy way of doing it. Give me just a second. Is to cover up anything that's not a like term when you're working with it. So for example, I'm going to work with my x terms first. I'm going to go ahead and cover up my constants. There. I'm going to pretend that they simply are not there. What do I have now? I have 3x, take away 2x, so 3x take away 2x, that's just an x, add another x, back to 2x. 3x take away 2x, just an x plus an x, when you get two x's together, that's 2x. I dealt with my x's. Excellent. Now I'm going to deal with my constants. So I'm going to cover up all my x terms. That's gone. That's gone. That's gone. I have 4 plus 6, which is 10. And that's the answer. I combine my x terms, I combine my constants, and I got an answer. I didn't change anything here. These are 2x plus 10 is still the same mathematically as this expression here. If I were to plug in any number for x, if I were to, let's say, plug in 3 for x here and a 3 here for x, I would end up getting the same answer. Because I didn't change anything mathematically, I rearranged it, I made it smaller. Looks different, same value, if done correctly. Let's do one more example. Let's go with 4m plus 3n minus 2m plus 6 minus n. Here I have 5 different terms, and I have 5 terms total and 3 different types of terms. I have an m term. I have a pair of n terms. N term. And then I have myself one constant. And just like before, I'm not going to cover these ones up, but you get the idea. I'm going to deal with one at a time. I'm going to deal with the m terms first. Sorry. 4m, pretend this is not here, 4m, take away 2m. So 4m take away 2m, that's 2m. 3n, I'm pretending all of this is not here, so I can kind of cover that up if it's difficult for you. I want a different piece of paper that's a bit bigger. Yes. So 3n minus n. 3n take away n is 2n, and it's plus because 3n take away n is a positive 2n. That's why I wrote the plus in there. And last but not least, I have a constant. It doesn't have a counterpart, so I just write it in, plus 6. And that's my answer. So hopefully you found this video lesson useful to you. And if you have any questions, just ask me during class. Thank you very much.